Okay, so let's start off with some direct modeling. Think about how kids would think about this problem. So they'd probably be thinking, okay, there's 6 cups. 3, 4, 5, 6 cups. And then they'd be thinking, okay, how do I show the removal of 2/3 of a cup for day 1? Well, I'm going to have to show thirds. So I'm going to partition these all so I have thirds. Okay, that's great. So now I can show 2/3. So on day 1, scoop out 2/3, feed it to the dog.
And then what I'll do here is show that mathematically. So we start off with 6 cups, and we scooped out 2/3 of a cup.
Okay, and then day 2 of the 2/3 of a cup of dog food for the dog. And then day 3. Day 4, day 5, day 6, day 7, day 8, and day 9.
And so we should have the subtraction equaling 0. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18 thirds. When we do our subtraction, we see all dog food has been produced.
Great. So our model, whether we're using pictures or whether we're doing repeated subtraction with the fractional notation, we're going to come out to 0. When we arrive at 0, we know we've used all the dog food and we can count the days. So I'm wondering, before we head towards any algebraic equations, if maybe we could just think about it as grouping opportunities. So what I did notice when I was doing this modeling, so here I've got 2 cups. I'm thinking to myself, how many cups of 2/3 are there in these 2 cups? So this was day 1. This was day 2. And this was day 3. Okay, so I had 2 cups of dog food, and I wanted to know how many 2/3 servings there were in 2 cups. And I've noticed that there are 3. Okay, well that's interesting because I have 6 cups in total, so I might say to myself, feel free to jump in anytime, Roxanne. 4 cups divided by 2/3. Okay, so then I'm going to have 6, so this is days. Okay, and then I could do some additive thinking. I could add 3 more days here, so I've doubled here. Or maybe this time I'm just going to jump right here. So I'm going to multiply by 3 instead. I'm going to go 6 cups divided by 2/3 servings, and I'm going to go times 3, and that's going to be 9 days. So I think we have some transitional thinking here. Kids are really thinking about the relationship between the numbers. They're noticing some things about when they're combining those 2/3 to make their lives a lot easier.
And then we could also represent it in a ratio table. So we see here 2 cups will serve 3 days. And just like Vince showed here, you can multiply by 2 to get the 4 cups for 6 days. Or you multiply that 2 cups by 3 to get the 6 cups that we had initially. And that will serve 3 times 3, 9 days. So we see the grouping and combining happening here at the transitional stage.
Okay, so now we're going to try to look for a connection between the direct modeling and just approaching it purely from the equation. All right, so in the beginning I had my 6 cups, and what I'm going to do is I'm going to ask myself, how many thirds are there in 6 cups? So I'll do my partitions, and so I'm imagining at this point that the serving size is 1/3 cup. There's 1/3 cups, feed it to the dog day 1.
Okay, and so if I was to represent what we saw Vince doing here, we have our 6 cups. He divided each of those 6 cups into thirds. And then he asked himself how many thirds are there in 6 cups. And that resulted in us getting 6 times 3 because you see there's 3 groups in 1 cup. So that resulted in an answer of 18.
Great. Then I say to myself, oh, wait a second. It's 2/3. So my serving size is actually doubled.
And in order to represent that, we have our 18 days, and because it's doubled, we have to now half that, and that gets us the solution of 9 days.
And that's exactly what we had when we were repeatedly removing 2/3. We got to 9 days. So how do we put that all in algebraically into one equation? Well, we could say, how many thirds are there in 6? And still going to have to deal with that, because this equation has to balance. Well, at some point, we're all going to recognize the reciprocal nature of multiplication and division. And when we look at this, it's easier to say, oh, 6 times 3 is 18. So the thing is that our serving size has doubled from 1/3 to 2/3. So the number of days is going to half. So then we've got 18 divided by 2. And so the final answer is 9. So aside from this, setting up your equations like this, at first, people or students are just going to walk it through in their heads. How many 2/3 are there in 6? Well, I know that there are, how many thirds are in 6? 3 times 6. There are 18 thirds in 6. But my serving size is doubled, so I would need half as many, so that's 9.